Okay, we're going to take a look at this example on the buoys and the full-blown example, basically, of what we're doing here. So first thing is that we're going to investigate the quadrilateral ABCD. Well, we don't have D, but it says the buoy D is placed halfway between A and E. So we know that we're going to have a point that's placed halfway between this line, and then we're going to be able to draw the ABCD. So halfway, we have to obviously use then our midpoint formula. And so we've done it here. We've worked out the midpoint for D, which is 1 and 25. So I've put that point on here, 1 and 25, which is D. So now I have my quadrilateral drawn. And now my job is to investigate this quadrilateral to see what kind of quadrilateral it is. So basically, I'm going to start with the distance formula, the distance of the lines to see whether I've got a rhombus or what have you, because if I've got all four sides equal, then I can pretty much stop at that point. So I'm going to use the distance formula, and I'm going to find the distance for AB. And be careful with your calculator. You need to make sure that you're getting these values, 24.7. Remember, if you're using a calculator in a single step, you need to use double brackets. When you put this thing in, you've got to use your double brackets, and then negative 14 minus 7 squared, and then plus a bracket 16 minus 2 squared with a bracket at the end. So you need double brackets to do that. There's 24.7. I do the same thing for BC, which ends up being 17.5, CD 24.7, and DA 17.5. So what I'm seeing here is that I have pairs of sides that have equal lengths. Pairs of sides that have equal lengths. Opposite sides have equal lengths. So this is equal length to this, and this side equal lengths to this. Right? So that's what I've got at this point. Now, that's not enough to prove a parallelogram. So we've got to talk about their gradients. So I'm going to look at the gradients of these lines. So I'm going to find the gradient of AB and BC and CD and DA. And so I've got the gradients. Now you need to show your working, right? So you need to put it in lowest terms, and you need to show full working for finding gradients. I haven't shown all the working, but you would do that. And now I see that I have AB has the same gradient, so it's parallel to CD. And I have BC gradient is the same or parallel to DA. So I've got basically a parallelogram. I've now proved a parallelogram. I've got two pairs of parallel sides, and those parallel sides are the same length. And not all the lengths are the same. I've got pairs of opposite sides that are congruent and pairs of opposite sides that are parallel. I have a parallelogram. Now, the other thing that it asks me to do up in the question, so I've covered this. It also wants me to do this, investigate the properties of the line CD and determine its properties, how it relates to both AB and AE. So AB and AE, so let's take a look. I'm just going to get rid of these lines. So AB, and what was the question? We want to see how CD relates to AB and AE. So let's do that. How does it relate? Well, CD is a bisector of AE. We know that because we know that D is the midpoint. So we know that. We don't have to do any more work with that. We've already shown that. But is it a perpendicular bisector? So it's a bisector. Is it perpendicular? So then you're going to have to find what the gradient of CD is in relation to AE. You need to find their gradients. And we've already done that. Up here, we found that CD is a negative 2/3 gradient, and AE, which is the same as DA, has a gradient of 3/5. So they're not perpendicular, because if you multiply those together, you do not get -1, right? So Line CD is a bisector of AE, but not perpendicular, so I've made a statement. AE, they don't have a gradient that when you multiply them together, give you -1. So you need to show any working about that. But really all you have to do is show that, you know, you've got these gradients here and they're not perpendicular to each other. So there's really not much that needs to be shown in the way of work. You've done all the work for it already.